I haven't taken one of these apart before, at least not that I remember. I'm sure someone else on YouTube has. Figured why not give it a go. This is a kilowatt. It allows you to measure the amount of power your AC devices are using. You plug it in and then you plug stuff into it. I stopped using it because I switched to this, which I find to be a little bit more accurate, but it does have some useful features, like it can log kilowatt hours and stuff like that. Anyway, well, let's go. Anyway, 3 screws. Speaking of the new camera setup, if things look weird, it's because the camera is upside down, essentially. I'm going to flip it around in post-processing. That was easy. So, separate input board over here. Has the input and then the pass-through output. So current shunt here. So we're actually seeing direct current measurement, which should be fairly accurate. By direct current measurement, what I mean is the current is passing through this shunt here. Where is it? Just a minute. Alright, now that I've flipped this over several times, poked it with a multimeter and said, to myself, this is direct current measurement, not direct in the sense that it is direct current, in the sense that the current is actually passing through the measurement device. I'm sorry if this is completely out of focus. The camera scales the resolution down quite a lot. I'm using an external display. I don't think this is going to work out. Anyway, the odd thing about it is that the live goes direct from the input to the output. That's the strange thing. The neutral is actually where the measurement is made. Comes in on the back here. It goes through this thermal fuse. Yeah, thermal fuse. Then through the current shunt and out to the output neutral. That current shunt comes up here to the ribbon cable over to the logic board. Power supply for the logic board is this capacitor here and this inrush resistor, and there is a tiny little fuse, 200 milliamps, which seems like a lot for a screen and presumably a microcontroller, but it is what it is. Single diode for rectification. The ICs that operate this are... Oh, okay. That's easy enough. Okay, the logic board is here. We've got a blob, probably some kind of microcontroller under here. This is an FT24 CO2A. It's an EEPROM. And this is an LM2902 quad op amp. So I didn't trace anything out, but almost certainly what is happening is that this is what we're getting from here. This current shunt is going to be very tiny, teeny tiny voltage. So that's going to go into the op amp and get amplified up, and then go into the microcontroller, which is going to, do some math and figure out what current that voltage corresponds to, and then put some stuff up on the screen and listen for button presses here. And that's about it. It's fairly simple device. I'm kind of confused as to why it isn't a little bit more accurate than it is, but presumably they're just not calibrated very well. Since it has an EEPROM, yeah, you would think the calibration would be stored in there and you'd be able to change it, but there's not really any user interface options for changing it. So, there you go. The AC connections, the pins, that plug in and that get plugged into, they're just soldered onto the board. There's no mechanical retention whatsoever. And these ones are actually, those are kind of wimpy pins also. So that might be why there's the thermal fuse in here, because if it gets too hot inside this thing, these might just melt and fall right off. And this is the linear regulator for the logic side of all this, and it's a 78L05. They're rated 100 milliamps, so 200 milliamp fuse. This is all gonna fry. Thought I'd plug it in. We're seeing the problem right away. It doesn't really matter how accurately it measures the amperage if it's measuring the voltage that inaccurately. It's going to give us completely the wrong wattage reading. But we might as well give it a chance anyway, right? Yeah, that's not very good either. That's pretty bad, actually. So as you can see, when the voltage is that far off and the current is that far off, you end up with a wattage reading that's pretty far off, and in a device that is essentially, its purpose is to read wattages of your household devices and tell you how much power they're using, and then log that as kilowatt hours. It's not really ideal. This may be a your mileage may vary thing. My unit's pretty old, so it might just be old and broken, but there you go. Inside a kilowatt and an accuracy check of a kilowatt. It's not very good. Bonus content, because something just did not sit right with me about this. So I mentioned the 78L05 on here that is regulating the voltage for the blob and the EEPROM there. But LM7805 has a LM78L05 has a maximum input voltage of 30 volts. So something else has to be dropping the rest of the voltage, and it also has a dropout voltage. It's not a low dropout regulator, so it has a reasonably high dropout voltage, looking anywhere between 2 volts and, what was that, 1.25 volts, depending on the load. We're probably going to be on that middle line there, and so we're going to be a little over 1.5 volts, most likely, unless it's significantly lower current. So like I said, there has to be something else regulating the voltage down, and there is. It's this Zener diode here is dropping the voltage, and then the output of the Zener diode is going to the regulator. So given what we know about the dropout voltage of the 78L05, we would expect somewhere in the neighborhood of 7 volts across this Zener here. But it isn't. It's 5.6 volts. And if we flip the board over to get at that regulator very carefully, since everything is live. Come on. Do have 5.7 volts, 0.6, yeah, close enough. 4.38 volts on the output going to the logic. And if we go ahead and assume that the blob is using its VCC as its reference voltage, that would account for why this is reading high, at least, you know, within 5 volts. We're about 12% off, 12% low, and we're about 12% high there. So I removed what appeared to be the offending Zener diode and replaced it with one of my own 7.5 volt Zener diodes. But that didn't solve the problem. I also discovered that the one that was in there was a 7.3 volt Zener, so it should have worked. What was actually offensive was this capacitor, which, if I can angle this so you can actually see it, is supposed to be 470 nanofarads, but it's actually 300 nanofarads. So I've replaced it with this brand new one, which is 470 nanofarad, actually measures 480. That's okay. Let's see what that did. Right in there. Now we've got 7.3. Just and 5 volts on the output. Hey, that's close enough for me. That'll work. So, if you've got one of these and it's giving you nonsense readings, check the power supply voltages for the logic circuitry. It uses it as a reference voltage for measurements, and check this capacitor. It might not be very high quality. I was able to check this in circuit. I didn't have to take it out of the board. I got the same reading before and after, so real easy check if that is your problem.